starting off with the picture code. All of this is from the code from class. One thing to note is that I made two new functions. One's called find line, and it finds the slope and y-intercept between 2 points and returns them. Another function I created is called average, and this just computes the average of a given array. So again, a lot of this is from the class code. So basically explaining my functionality behind this code is that I was able to differentiate the left and the right code, left and right lane by figuring out the slope. So I created 4 arrays up here for the left and right lanes and for the first and second points. And I used my function of find line to figure out the slope and y-intercept of these points. So I was able to calculate the slope and figure out if it was on the left or right, and then attach it to these arrays that I created. Down here, just to make it easier on myself, I converted them into arrays, which was a lot easier to work with for me. And this was applied by using the average, and by using these arrays, I was able to pick out all of the rows and then pick out like each X or Y accordingly. So I did it for the right side too. And then I found the line between these points, because this is the average point for the screen. So then I figured out the slope and y-intercept, and that was able to help me because I knew that I wanted to plot the lowest point, the y1, at the most bottom point of the window height. So I figured out my y1, and then I used my y equals mx plus b to figure out what the x1 should be on that line. And again, I did the same thing. I kind of approximated where I wanted the y to be, so I just said it was like 2/3 of the height of the window, because I didn't want to get the line too far ahead of itself. And then I figured out the x, given the y equals mx plus b equation. And those points were for the snip, which in the classroom of code we reduced from the original window size. So basically I had to translate that back to the original window size down here by fixing what the y point was. So I had to scale the left and right slopes and find the line again between these two, given our new window size. So I had to fix my y's up here, figure out the line of them again, and then again I had to find another y point, and then using my y equals mx plus b, those new ones, I figured out the x's. And finally I could plot them on the screen. So now moving on to the video code. This is the first video. As you can see, it's pretty jumpy. I think that this would be solved if I was averaging across multiple frames, but due to my lack of 1, Python knowledge, and 2, lack of time, I was not able to figure this part out by averaging the entire code. But one big thing about using this code is that I had to figure out the video capture functionality, and that is just to bring the video in so that way it can be read. So moving down here, it was while basically the video is playing, it would take in an image, and this is just 1 frame of the entire video, and it would use that to figure out the lane. So it would keep doing this repeatedly. Another big thing with this video compared to the picture is that the window size was different. So I had to subtract by a different number to figure out the perfect snip. That way the mask would also show up correctly. Another thing that I had to work with was that sometimes the arrays would be empty. So down here we were averaging, and I was selecting out multiple columns and rows, and that caused a problem within the code. So I had to basically say that as long as there is important data in there that I need, then we're going to take the average. Otherwise, the data is empty, it's not important. Now for the second video, you can see in the beginning there's a lot of sun exposure, so the lanes aren't able to focus, and then finally the camera goes into focus and the lanes are okay now. Again, I have the averaging problem, so the lanes are a little bit jumpy right now, but one of the big things that I changed in this code, again, it's pretty similar to the last video. The only thing was that the window size was the same, but I did have to change the mask around because there is a white point. There's a bunch of white lines over to the right over here once one of the lanes comes onto the highway. So I had to fix the mask so that way the lanes would not focus on the other lanes coming onto the highway. Therefore, I had to make a smaller mask. And another thing is that since this is in such bright light, I had to make the threshold a lot higher. Again, a lot of the code is the same, so I won't explain that again. Some changes that I thought might be good for this code is something that could detect the dark versus bright days. Again, I had to change the threshold, so if we're able to figure out the threshold automatically, then apply a certain code for it, that would be really good. And another thing would be to keep a consistent window size, because I was having to mess with the window size a little bit, and sometimes the mask